So I'm Luc Julia. I'm a French engineer working in Silicon Valley for almost 30 years, and I'm today in charge of innovation at Samsung. So when I was a kid, I started to play with electronics first, and then the computers came when I was about 15-year-old. So it comes from there. I started to play with computers, the very first computers at the time, the personal computers, and started and didn't stop. At the time, there was only a BASIC that was available, but I was programming in assembly language. What was interesting was to be sure that the computers could talk to humans and humans could talk to the computers. And because of that, I did what was called HEI at the time. And I had to do some signal processing, because when you want computers to talk to you and back, you need to have the computer grabbing the signals, understanding the signals, and so that was the best way to do that. And speech recognition and gesture recognition and everything recognition was my specialty. And then it was of course everything around AI, because when you start to understand the signals, this is AI. So I did my PhD here in France, but I did my postdoc in MIT and Stanford. And some people decided inside the lab that it was time, maybe now, because the technology was kind of good enough, it was time to create a company. So SRI is a spin-off factory. So I was working on what is called multimodality, which is basically trying to put all those modalities together in order to create a message for the computer. But speech was kind of the easiest one, because it was easy to have. It was easier at the time to have a microphone, in the computer than having a camera. But it doesn't mean that it was easy to recognize, because speech recognition still today is a very difficult problem. Especially not the recognition itself, the recognition of the words, but the recognition of the meaning, which is called natural language. All those things that are not verbalized basically are very difficult, to grasp. At SRI, we are doing some applied research, much more applied than anybody else in the group. So that's why we created CHIC, that was an applied lab, where we created a bunch of products. And in 1999, I decided, that it was good enough, and that we could now go to the real world to create startups, doing pretty much the same thing, but this time, testing the products with real people. The nice thing about 1999 and 2000 is that, again, it was still the beginning of the internet, and it was easier to test products, with real people, because you just had to put it on the internet in order for people, to play with it. Back in '97, it was the beginning of the internet, really, the public internet, right? So it was starting to come, and there was no Google at the time. There was, no way to really find something on the internet. And we thought that it was a good idea to try to find something on the internet through speech. So that was the idea of the assistant. It was assisting us to find the right information. It took a long time, because the product was kind of ready only in 2007. And Adam, created a company at the time that was called Siri. I wasn't in this company because I was doing some other companies, because I decided in 2000 to create other startups. But so 2007, they created a product around this assistant. The phone, just came also around 2007. So it was a natural way, basically, to use speech there, because there was a microphone in this, phone, obviously. And so Jobs had the vision to say that it was something that was going to be very interesting to have an assistant in the phone. And I decided to buy that in 2010, and it was just, it went to the public only in 2011. He actually asked me, to come back, because it was our baby that we were going to develop, right? So Siri, the company, it was about 150,000 users 150,000 users. I mean, well, you know, you can do that in your home, basically, you know, with a server, so that's fine. Here we knew that we were going to have 300 million users. So 300 million users, it's a bit more difficult than 150,000. So the challenge was to be sure that the system was going to be scalable, and was going to be able to deliver, you know, the performance that we needed, because when you have a speech recognizer, you also need something that is going to be, you know, with a good response time. I had the chance to be in charge of everything on the Siri side. Everything meaning, I mean, of course, we see, you know, only the part that is the interface, the voice interface, but there are a lot of servers and a lot of backend. I mean, it's a complex system, very complex system with huge backend, right? And so one thing that Apple didn't have at the time was actually a backend, even though, you know, they had iTunes and stuff like that. I mean, it's not the same kind of backend. You know, iTunes is basically just, I'm going to put, you know, quotes, just storage, and we needed a lot of compute in order to do Siri as well. So we had to build actually the full, you know, backend from scratch. I mean, so we knew that the architecture, you know, we built an architecture that we knew could work, but we had to build it, and physically building it, you know, buying the servers, buying actually the actual data centers themselves. It was just, you know, challenges everywhere. What wasn't that great, you know, is to explain to the big company, and especially, you know, a company that is kind of cold feet, which Apple is. I mean, that you want to, and you need to add some new services to the product that you are developing. When you look at Siri, the company, they had about 17 services. And when you look at Apple, you know, in Siri at Apple, it was about 5 services. And of course, you know, we wanted that more and more and more, but adding a service means, you know, adding a partner. And I mean, those large companies, sometimes they don't like to work with partners. They prefer to do the thing themselves. And we saw that with maps, for instance. You know, they wanted to do maps themselves, and we saw that it was a disaster. The difference between a startup and a large company is the means that you have. And so when I went to HP, I mean, the means were, you know, huge. I mean, they gave me the very first day 250 people, 250 engineers, which is, you know, about 10 times what I used to have. So managing that is different, and actually also again, here we are in 2010 now, right? So 2010, 10 years ago, in large companies, what we call today the agile methodology wasn't there. I mean, it was water flow methodology, so you plan, you know, for 6 months in advance. I mean, exactly what you don't want to do in modern software, right? So, I mean, one of the things that I brought there was agile. And so agile with 250 people that are not used to that, it was a challenge, but it was a very interesting challenge. And we built also a new product that wasn't, you know, at all something that HP was doing. HP is very good at printers and stuff, but they didn't have an idea of what a connected printer could be. So we created what is called ePrint now, that is the first connected printers, and we actually sold something like 80 million the first year. So there is something that you call smart things today that Samsung bought a few years ago, and so there's a backend as well there. The backend is basically something that allows, this is a cloud that is an IoT cloud, and the IoT cloud allows to connect the Samsung devices as well as some non-Samsung devices. So this is very heterogeneous environment, you know, and so you need to be sure that everything is going to talk together, and we actually worked on that for 5 years. Also, I wanted to open something here, and we did open this lab in June 2018. I really believe that, you know, the French engineers are very good, and so I really wanted, you know, to take advantage of the new era in which France, you know, entered back in 2012, 2013, when entrepreneurship, you know, became again something cool. And so because there are, you know, that many startups, in France, in Paris in particular now. I mean, I wanted to take advantage of that because, I mean, my time, engineers, after school, they were just directly going, to the large companies and, working in the large companies forever. The new trend is that, I mean, I heard recently that 60% of the students, in those engineering schools, they want to create or go to work for a startup. So it means more, I mean, a dynamic environment, and it means also that those people, they are going to see something, they are going to be, I wouldn't say more capable, but they are going to be exposed to a lot more things, so they are going to be more flexible in terms of projects that we can propose. So that's why I like French engineers. AI is too easy, in the sense that, I mean, it's too easy because you just, throw a lot of data to a bunch of CPUs or GPUs or whatever PUs. And so it's easy, and you can get some results. You can try, you can fail and you try again. And you actually use a lot of resources, both in storage because of the data that you are using, and in compute because of the different trials that you are doing. So I think that we don't realize that very well because, I mean, those CPUs and those resources that are somewhere, in data centers, you don't feel them yourself. Sometimes you have your own computers. When you have your own computers, next to you, you realize that they are actually, working, and it's kind of a warm environment there. So you feel it, but when you are using, just the AWS or the Microsoft Azure or whatever, I mean, you don't realize it. So it's too easy. And so being too easy, you don't realize how much energy you're actually using to do what you are doing. And so at one point, we need to realize it. So I'm trying to explain, all the time that we need to be very careful. And I hope that people, will be more careful at one point. And I think that because we are going, frankly, directly in the wall, with those techniques, I think that at one point regulation will have to intervene. I mean, the very first assistant that we were talking about, back in the 90s, it was a speech assistant. Here it's going to be an everything assistant. And it's going to be a bunch of assistants because there is no AI that is going to be, a general AI. So general AI, I don't believe in it. It won't happen, using just mathematics the way we are using it today. But there will be a bunch of assistants in every domains, right? So we are going to see assistants in the medical domain. We are going to see assistants in the transportation domains. I mean, we are going to see AIs everywhere. So the way it's going to evolve, I mean, there are some obvious things, like, for instance, in medicine, I mean, it's of course, the DNA, for instance, is something that is statistically very, very interesting. So we are going to see, DNA being decoded and help to fix through machine learning, through deep learning, because it's a lot of data, it's a lot of interesting statistical data. So, of course, that is obvious. And I mean, all the domains will see more and more and more of those assistants. There are some people that might be thinking, about something else. We are thinking about, doing physics with quantum computing. We are thinking about doing biology with biocomputing. So the reality is that those things are very, very, very early, right? So quantum computing may be a little bit less early, but it's still very, very young. Biology, we are nowhere. If we were to believe that there is one day something that is going to be close to our own intelligence, that is going to be actually this general intelligence that some people are talking about, it won't be with mathematics. I don't think it will be with physics, because the quantum is actually applying mathematics in another dimension. It might be biology, because biology is actually the closest thing to our brain. But there, I mean, we don't know. I mean, we don't even understand our brain. So, I mean, to build one is going to be very long.